Oh, okay.
Ready? Go.
All right. Hi. We are LO1A. I'm Allie. I'm Natalie. And this is our presentation for circuit fabrication.
Sorry, I didn't know I was
Okay. So we were lucky enough to be the first group to go through almost every single lab. So if something was messed up, we were the ones who figured that out. And if you had to take only 4 profilometer photos, we had to take 24. So you're welcome. We stayed an hour after this lab. So our first was interlayer creation. That was the board we were given. 20-second exposure development. I kept misaligning the mask. So I had to take it off and redo it. The Mylar film kept coming off. And so we had to replay that like multiple times. And the photoresist kept getting stuck underneath the mask. So I had to kept taking it off, all the photoresist off and putting it back on.
Okay, and then for etching and stripping, board one was in the stripper for like 12 minutes, and there were very large chunks of the photoresist still on the board. We had a lot of problems with that, so we had to take the board out, scrub it a lot, and then put it back in, and then looked at it under the amscope a few times to see if we actually got it all off. Which it looked like we did, but I don't think we actually fully did, and you guys will see that later. So board one, L2 before and after etching, those are our profilometer photos. They both were not great, but we had some of our other photos, our other profilometer photos that actually turned out really good.
So yeah, for multi-layer pressing, when we our board one was already done for us when we went into the lab. So all we had to do was take it out. And then so for board two, when we cleaned it, we didn't dry it fully. So when we were doing the stack up, we noticed that the pre-preg was wet. So we had to take it all apart and redo it. But then after that, it was fine. Um,
Thank you.
this is our give it like our downloaded versus like what it's supposed to be, like our measurements. And it looks about the same. I think I just plotted it wrong because I don't know how to use Excel. And then for our fuel strength test, we kept zeroing out the clamp wrong and we kept missing like the peeled up part with the clamp. So we would start running it and then it turned out it wasn't clamped on to the copper. So we had to keep redoing it. But eventually, when it broke, we got to work and it broke like on a diagonal, which is really odd because normally it breaks like straight across. So that was something weird that happened when we were doing the peel strength test.
Okay, and then for drilling, the holes were misaligned due to mask misalignment, so you can see our holes there. Like almost all of our holes aren't aligned, but it ended up being okay because most of our boards ended up working. Aspect ratio. So in this lab, we asked a really stupid question about not knowing what aspect ratio was. We do know what it is now. It's thickness over diameter. And but we didn't actually calculate the number for our post lab, so we still don't have that number because we never took the thickness of the board at this stage. So that was just a silly thing we did.
Yeah. So electroplating, I actually did this lab by myself because Natalie was on her deathbed at the time. But it was really easy. Just basically sat there the whole time and waited for timers to go off. The board came out looking really nice and pink, and the all the holes were fully plated. I learned what that copper tape was a real thing, and so got to use copper tape. And the 19 micrometers, that's what the manual says. We were supposed to get in 2 hours, and we calculated we got 16.8 in 2 hours in our holes.
Okay, for outer layer creation, our exposure masks were actually put on backwards for board one, which wasn't great, and then we had to flip those around. The Mylar kept coming off again. We had a lot of issues with our labs this semester about actually having our Mylar stay nice and flat without any bubbles in it. Etching took a really long time for this, way longer than expected. We had expected, I guess, more like the inner layer creation times, like for this, but I guess the copper is thicker on the outer layer, so it actually took us a lot longer than expected. So board one took us about 31 minutes and board two took us about 22.5 minutes, but it ended up looking good in the end though.
And for electrical testing, our first board, we got a 100% yield. Every panel worked. But then for board two, only 5 out of 6 panels worked. So on panel 4 of our first board, we ended up having a little bridge between LED 6 and the ground. And we found that by going through the X-ray machine, and you can barely visible right there. And so we found that, and then we went back to actually our lab 2 AOI scans, and this photo is from lab 2. So like we could have technically could have caught it, but we weren't looking for it. So that bridge has been there for a really long time.
See the bridge that we have.
And then solder mask. I messed up board 1 when I was putting it through because I kept pushing and pushing and pushing it in, and it just wouldn't go. It went in on a diagonal, and then like a lot of the solder mask like pooled right in the center, and so I gave it to Middlebrook, and he just like stripped it, and then we redid it, and it came out looking good. And then you want to talk about the
Yeah, so okay, for depaneling, when we finally got our solder mask to actually like look nice and actually be on the board properly, we put it into like the thing for depaneling, and our edges turned out a little rough because there was a lot of chattering in the machine. So yeah, our edges turned out a little rough, and there's a picture of that.
we got photo bombed.
Yeah, we had to put that in there because it's pretty funny. For legend printing, so we're the first people to do this lab, so we were like the first people to use this machine. When we had put it in for, I think board 1 side, like top layer, we had some fading towards the end of the printing, which was kind of abnormal. Ben said he hadn't really seen that before, so we're not really sure why that happened, but we didn't actually put a picture of it on here, but we have a picture of it. But panels 1 and 4, the silk screen on it is a lot lighter than the rest of them, so it ended up just fading towards the end. But it's not super visible. The offset on the legend was very minimal. For board 2, our y-axis offset was like literally perfect. It was like dead center. And then for board 1, it was a little bit off-center. This first picture is from board 1, and the second one's from board 2. And then we just measured like the difference with like the amp scope of like, we knew where it should be lined up, so we just measured it with that and then compared the measurements.
So we're really bad at microsectioning. So everything that says NA, we completely just grinded through that hole. So really only our puck 2 for board 1 and board 2, we were able to get like real like accurate measurements off of. So we labeled it like 1 to 7 and then 1 to 7. So that's how we got our measurements. And yeah, we're just really bad at microsectioning. But theoretically, if all the other boards are like, or all the other pucks were like puck 2, both puck 2s, we did a pretty good job, but we just overgrinded all of them.
Yeah, I think it's also important to note that our pucks are actually like probably not labeled properly how they were like they were in the samples on the board. We didn't actually label them 1, 2, 3 before we popped them out. So they're separated correctly like board 1, board 2, but in like the order that they were on the board, it's not right because we mixed them up before we figured out that we should have labeled them. So there's no way for us to really go back and like actually like look at any past data with them because it's probably not going to be compared correctly.
Yeah, so for the sober step, I'm very overconfident when it comes to using the UV exposure machine. Like I'll be like, oh, 20 seconds. And then probably instead of hitting set, I hit start. So then when I start to close the machine, it sets the UV off early. And so like by the time I got the vacuum on for the 20-second, it ended up only being like 17 seconds. So we just did our date off of 17 seconds instead of 20 seconds. So that probably messed up some of our numbers. But yeah, we just decided to measure the smallest trace width, the 9th, and then the largest. And it turned out pretty good, besides me messing up the exposure machine.
Okay, so for photo plotter, This was our very last lab that we did, and we ended up using station 1 and 2 because there's something wrong with station 2. So Ben had us test out both of them. So I guess I just put in here that station 2 wasn't working, and that was the one that I did. We didn't actually end up taking a picture of it because Ben took it away from me before I could take a picture of it. So, and we don't have it. So, but our actual one with station 1 turned out really good, and it was really nice. We took all of our measurements and got our percent errors, our differences. So it ended up turning out okay in the end. Okay. Are there any questions?
Quick question from the audience before we. No, all right, thank you.
A few things in our slides that I realized. Oh, I had that, but. I'll go.
Surprise, Alex.
I thought
You have no AI pictures, so you're losing our slide.
I don't know about that. But sure.
Like,
There's so much cooler.
All right, whenever you're ready, gentlemen.
This is our PCB fabrication presentation. I'm Isaac.
I'm Alex.
And here's just a little bit of an overview of what we're going over today. So we'll just go through the process of labs 1 through 12, goals as summaries, and like all the equipment or chemicals used. And then the analysis will have some AOI, X-ray, and measurements before a short conclusion.
So process diagram for the lab. So photomask for like the layers were created. We didn't do that. That was done by the TAs ahead of time. And same with the drilling of the fiducial and press pull pins on our original substrate. But then we worked through that. The inner layers were created in those first 5 like steps, which was in 2 labs. Then we pressed it. We drilled our via holes, plated our via holes. I messed that up. Plating happened after the outer layers, and drilling did too. That's on me. Then yeah, we did solder mask and pick and place, and we flowed our components on the board. So yeah. And then the stack up in the lab, we used Dynamask 5016 solder mask. That is 1.6 mils thick. We used 0.5 copper foil on L1 and L4, which got plated up. Isola prepreg for our laminated prepreg, and then we used Isola for material for our core.
And then we have some short lab overviews.
So the first lab we did was the photo plotter resolution test down in the sub basement. We had one of our so yeah, we used the Film Cell Plus photo plotter and AmScope microscope for measuring values. And we used the ideal line chemicals and film. We did that in the darkroom. There's no film out when that photo was taken. But those were our films that we developed. One turned out the low resolution one turned out very faint. And we're still not exactly sure why. Yeah, but our high resolution one measured accordingly, and
Yeah, we had some problems like measuring the low resolution because it's just so like horrible. So we ended up using like somebody else's
yeah.
of those measurements.
Yep.
For lab 2, we did the inner layer creation, which is lamination exposure and development. And we did that with the cantina for lamination, and then adding those masks on. It did take quite a while for every time we did a mask to like line it up properly, but it was definitely worth the time, as we'll see later. Then we used the Vortex with the exposure unit for 20 seconds, and then the splash with the potassium carbonate, and we used that LDI 7330 for the lamination photoresist there. And then we went over that and compared it to the design sizes with the Keon's automated microscope. We also did the week after we did the etching and the stripping, which we took those same boards that we eliminated and developed, and we used the splash in the other room for the cupric chloride, and then we stripped that with the LDI stripper for a couple minutes there, and then We rinsed them all off, made sure we get all that photoresist off, and compared that again with the same Keonce microscope.
For the pressing, the outer layers and the peel strength test, our peel strength test, we had some issues with the USB drive we were using. We did not have our little lab one at the time, so we're using a different one that was formatted. And it apparently needs to be FAT32 to work with that. Yeah, so the goal for this lab was to test peel strength in accordance to the IPC standard, and also with some test coupons we got, and then also press our boards. And we use the LPKF multi-press to press the board with our Isola prepreg and our 0.5 ounce copper. And if you look at these graphs, this is our two panels. It's kind of hard to see on this TV. I should have probably made them black or something, but that kind of faint line is our expected. And same with like coming down, it kind of comes between the blue and the red there. Coming down, it also is kind of between it. And that's our actual data that the press gave us.
Billion via is pretty straightforward. We used the file given and we just uploaded that, made sure that we had the auto level R on, and just lined that up with the print holes, and we really didn't have any problems. We had a little bit of burring that we had to sand out, but it was pretty successful overall.
For the electrical plating, we used the LPKF S4 line to plate it, and we used all of their chemicals for that. When we were plating it, the first board where that was direct current plated was put in by Dr. Middlebrook ahead of time, and we took that out, and then we paired and got the plating process started for reverse pulse plating board, which was our panel 2. This is panel 1 after it came out with the distilled water kind of made the copper headlines from oxidation and stuff. Yeah, and that's our board in the plating solution.
For outer layer creation, we went through the same process as inner layer creation, but we did the labs 2 and 3 like at the same time, essentially, with the lamination, exposure, development, and etching and stripping all in one lab. And we used those same materials, the LDI 733 for the lamination and the potassium carbonate for the development, and we use that same 20% with the Vortex. We had no issues with any of that. The etching definitely took a while. On board 1, I don't know if you can see it too well there. The etching got all the way through all of the boards, but on the outside there was a lot of like excess copper. And we didn't want to over etch, so we just left that. It didn't interfere with like any test coupons or anything, but there's definitely like a couple big strips of copper just hanging out on the side there.
These photos were taken after 2 5-minute cycles, so about 10 minutes into the etching process.
Those little strips should be shown later on with the scans.
So for electrical testing, we checked different nets on the board for continuity, and then also checked shorts to both ground and VCC. And we used the PCB Byte flying probes to do that, and the Fluke ABA08 A multimeter. Just to note that both of our panelists had 100% yield in the electrical testing stage. Yeah.
For the solder mask application and depaneling, I got a little impatient with the solder mask. His was finishing through, and I put mine through like at the same time, like when it was just coming out. So it caused like a lot of like blanking on the word for it.
Like build up.
Yeah, right at the top there. As you can see, like that's the strip of solder mask that all of it like went into one area right at the top. It
You can see how there's
Yeah.
just like film right here, and all that excess mass got built up right there.
Yeah, so we think that it just like snagged during the machine and it just like slowed down everything and spun, yeah. So that caused a bit of a problem. And then the depaneling went pretty well. We had to make sure that with the depaneling that thickness difference with board 1, which had that issue, didn't like cause any issues with the Carvera machine itself.
For the legend printing, we used a UV inkjet printer and deposited a white silk screen on our solder mask. You can see in that image kind of how we measured. So yeah, we used the ZZ1S UV printer and UV ink. You can see kind of how we measured offset. We measured from the far side of the pads where it's supposed to be centered in along that axis, and we picked a component that was both rotations. So we got like X offset and Y offset. And then we tabulated that. You can see our percent offset is pretty high, but if you think about it like logically, it would have to be over 100% to be actually in the pad, where it's dangerous. So it's fine. And that was just taken by taking the absolute difference between, between them. I think so.
For microsectioning, we failed to properly level them. So as you can kind of see, some of the holes aren't even like through yet, like for panel 1 bottom, and some of them are completely like grinded out. So that was definitely a big failure. And just making sure that those are like evenly leveled would definitely be something that we would go back and do if we could. But we used the MetPret grinding and polishing machine and the AmScope to like both measure and like make sure that when we're not grinding, over grinding or under grinding as much as possible. But it is very difficult with that angle to try to get all the holes. So we were shooting for 3 or 4 holes within 10% tolerance of IPC. And we were able to successfully get at least 3 on all of them.
I know for a fact that these two, so the top sample and the bottom sample from panel 2 were all the holes were within the top one 5%, the bottom one 10%. That's why there's dimensions on it. And then for that also to know our acrylic was setting well as we were pouring it in, so there was some big air gaps on the first couple pucks we poured.
Yeah.
And then we did photoresist exposure testing to determine the exposure level we should expose the photoresist to fall within the 6 to 8 steps held that is in the data sheet for the DuPont Ryston LDI 7330. And we use the same equipment for that as we've been using in the rest of the lab. And we used 1% potassium carbonate. I know different groups use different percentages for that one. We found that our 20 seconds exposure was the closest to holding that 6 to 8 steps held, at around 7 steps held. So
just something interesting to note. One of our it was the
20-second one. When you set the timer, if you don't press the red button to like lock it in, if you just like let it like keep blinking, it'll automatically start the exposure. So the vacuum was not on the entire time for that one. But the other 2 had the vacuum on the whole time.
Yeah, but it was interesting that the one without the vacuum had the best results still.
Yeah.
And then we have the analysis section.
So for the yield, as mentioned before, we had 100% yield on our panels electrically. And so there was no real need to x-ray the boards to see that. And also the x-ray dongle was corrupted at the time. So we couldn't if we wanted to. But we retroactively scanned PCB1 on both panels just to look at the via breakout. So if you want to go to the next slide. So that's panel 1 and panel 2, PCB1. And as you can see, like in general, I looked at most of the vias, just kind of moving the x-ray around. And I don't think we had like any breakout on any of our vias, which I think is pretty good. There's some spots that were kind of close, but I don't think it was anything was proper breaked out. If you look at like the, on the fully etched away copper around them. Yeah, and then we did AOI scans on every layer of the process. So we're gonna go through the next couple slides, kind of not quick, but like just 1, 2, like through them, and you'll see going from the bottom solder mask up through the top solder mask. So,
How many more you got?
just a few. So, yeah, nothing. And then trace width comparison, for whatever reason, on panel 1, the layer 1, and on panel 2, layer 2, traces were a lot thicker than the other traces. That's a graph. They deviated from the point for design size. Then we also had some, if you look at our etch back graph here, the blue columns are our photoresist thickness of trace, and our red is our etched copper average thickness on the different layers. And then we were thinner than we estimated we would be, is basically what this graph said, that table says.
Yeah, and then he successfully manufactured 2 4-layer boards. Thank you, Ben, Emily, Middlebrook, for guiding us through the lab, and then we're excited to have working boards to take home and reflow the second board later this week.
Okay, well, let's get on. Your thoughts?
I think we go over. That's why you was presenting it. Could be us.
Okay, so my name is Matteo Mazzola. My name is Emerson Barnes, and this is our PCB fabrication presentation. So the goals of our lab were to simulate a manufacturing environment and piece by piece make a printed circuit board. We used SOPs and machines similar to the ones used in industry in the hopes to have some boards to bring home. So we started off with the Stouffer step. Now this was kind of a lab designed to see what the best exposure times were. So we took 3 different Stouffer steps and put them through for 10, 20, and 40 seconds. We found at 10 seconds, it was like not very clean picture and you couldn't see a lot, and we weren't in that 6 to 8 range. And then for 20, it was nice and crisp and in between that 6 to 8 range. And then for 40, it was in between that, it was over, and we weren't able to see our smaller traces. Then for photo plotter, so this is where we're exposing matte film, and this is kind of how you create a mask. And so what we did, we put it on the photo plotter, ran it on the high and the low, and we got both those images there. And then we kind of noticed a black splotch, which we think is from prior exposure. I'm not quite sure how that smudge got there. So the first real lab for our board was the interlayer development. We started with our substrate and we laminated it with photoresist, and we taped on photomasks for the different layers. Then we exposed them using the 20 seconds we found in the Stauffer step lab. And then that made sure that only the photoresist that we wanted to stay around after development got exposed. Then we ran through the developer, which removed all the photoresist that was not over where we wanted traces to be. And that was our interlayer. Next, we had the etching and photoresist. So the etching, we use copper chloride to get all the excess copper out of our copper traces. And then we put it in the LDI stripper to get rid of any photoresist that could cause discontinuity in our panels. So now that the inner layer was done, we moved on to multi-layer pressing. We made the stack up shown in that picture on the top right there, using pre-preg as a sort of glue and copper foil to make what would become our outer layer. We placed it within the presser, which used high temperature and pressure to make the entire stack up stick together. Once it came out, one of our group members accidentally touched it without gloves on. And that led to a smudge. You can't really see it great there, and it caused no issues later, but it was unfortunate. So now we have our drilling vias and mounting through holes. So this was pretty easy lab. We vacuumed off the Corvair Smart Desktop CNC machine. We put it in, aligning the press pin holes, then taped it down. And then unfortunately, we had kind of an issue with the Carvera, and it didn't want to run through the program. So it'd do like 3 holes and then it'd stop and we'd restart. And then luckily Ben figured it out. We were able to get all of our holes through, and then we were able to deburr both sides. So the next step was electroplating. Now that we had these holes, we need to make sure that they were actually conductive. So first we ran it through 2 cleaning cycles in the Contact S4 plating line. And then we soaked it in activator and removed all the activator from everywhere besides inside of the newly drilled holes and vias. Then we put it in the copper plater. So how the copper plater worked is that it had copper ions that were attracted to the activator that was inside of the holes, which over the course of a 2-hour cycle built up a copper layer so that it was actually conductive for later. And then our outer layer creation, so this is basically the same as the inner layer creation. We laminated and then we exposed for 20 seconds and then developed it. And then we also did etching and stripping. And so the outer layer created.
So electrical testing, this was obviously a very important part of the process. There were two types of tests that we did, conductivity and electrical shorts. Conductivity ensured that any two areas that we wanted to be electrically conductive were, and shorts made sure any two that weren't supposed to be connected weren't. So we got through conductivity perfectly fine, both panels, all boards. And then we did the short testing. Between 7 boards, we had a total of 31 shorts, which was bad. And so then we brought it to the in-house X-ray to try and find where all these shorts were, and we were actually having a lot of trouble finding them. So Ben recommended that we go through and look at our AOI pictures of each layer and try and see if we could find a layer where these shorts are present. And we were able to find it on our layer 3. So that way we could find our issues for later. And then because we wanted to fix some of our boards, we had 7 boards with shorts, we were given 2 options to potentially fix it from Ben. One was to use a knife and cut the copper so that there was no longer a short. The second was similar to how a fuse works. These shorts are really thin, and if you run a lot of current through it, well, they'll blow. So we started doing this with very low amps, maybe an amp, and we actually fixed a lot of them. We fixed, I think, 3 total boards. We have 1 totally working panel and we fixed 2 on the other panel. So the only issue was the rest of them, we think that the shorts were on the vias, which has a lot more of a copper surface area, which meant they're harder to blow. So we thought we needed more amps, and we did. So this led to some issues you can see here. It's hard to see, but that is a cherry red via. Some issues, some blasts, and some scorch marks that I hope aren't still there. But we were able to actually fix a lot of our boards, and 4 of them will never work again. Unfortunately.
So solder mask application and depaneling. So this is kind of the same as our inner and outer layer creation, except instead of using LDI 7330, we use Dynamask 5016. As you can kind of see over here, we didn't realize that you have to push the board kind of really hard to get it to go through. Like it doesn't take as well as the 7330. And so it kind of was like sitting there and we're like, what are we doing? And then we got a little burn mark from it just kind of sitting on those rollers. But the second one was fine. We realized we had to push it through. And once it was through, it was all good. Then we depaneled. We took it over the Carvera Smart CNC desktop and it was not working. It was giving us trouble. We were restarting and me and Mateo actually weren't able to do it. So Dr. Middlebrook thankfully got it working later and depaneled it. And depaneling is just removing the boards. So, yeah.
So next was legend printing. This is actually adding UV ink to the components so that later when you're soldering on, you can actually know where things are supposed to go. And we also added some decoration. For reasons we're not entirely sure, it was coming out really faint. So for each face, we actually had to run them twice. And for some reason, some of them came out a little blue. We're also not sure why that is. We think that it came out faintly because of the clogging. The blue thing, we do not know. But legend printing turned out fine. And we were able to test the accuracy of it, seeing how far off from the center of the via it was. And none of them were more than 0.08 variance from each other. So we thought that was acceptable accuracy.
So next we had microsectioning. So we were the first group that Dr. Middlebrook got the bubble remover. And so we mixed acrylic liquid and acrylic solid and then put our boards level at the bottom of the containers. And so when we put 3 of them in the bubble remover, this is what we ended up getting, which is more bubbles, which was nice. And so we weren't able to properly microsection those, but luckily for the second ones, we didn't use the bubble remover. And then we were able to take them down to the grinder. And one of them, I completely blew past all of them. And then we were able to do 2 of the pucks we got close to the middle, and we're able to microsection our copper thickness. So, yeah.
So this was not an official lab, but this is something we wanted to do, was the actual component placement. Thankfully, Ben walked us through all of it. It was very cool. The first step was solder paste placement. It has a machine that actually puts the paste on the pads. This doesn't actually hold the components in place, but later it would become solder. Then we brought it to the pick and place machine, which actually uses a camera to place all of the components, which seemed really cool until we brought it to the AOI machine, which checks how the components are placed. We found 80 errors. This was not a very accurate pick and place machine. So me, Emerson, and Ben went through with a pair of tweezers and moved all of the tiny components back into place. That took a while, but it worked. And then we brought it to the solder reflow oven, which actually made the solder paste we put on earlier harden. And so now that all the components were in, all we had to do was do some hand soldering, and we were able to get 2 working boards, one for each of us, which was amazing and wonderful.
So next we have some data. So this is our press plate heat temperature that we got. This is our peel strength values, and then this is the thickness of our traces and our through holes.
So our final results of this is we had 2 working boards out of our 12. We had a lot of fun with it. We learned so much about PCB manufacturing. PCBs are in everything. We've probably all seen them or held them, but actually making them gives you an appreciation for how difficult they are to make. But we learned a lot. We have a new understanding and passion for PCBs that we did not have before. We had some issues like the burn from the laminator. We had some over-etching issues. We had a crazy amount of shorts, all things considered. But we ended up with 2 boards, which is all we needed, and we are very happy.
So then just some cool pictures. So this is our fully working board here. This is the whole board all populated. And then this is tombstoning, which is why we couldn't use this one, because this solder sucked it straight up parallel. It's actually really cool. And then this one's like a little tombstoning, but it's just kind of up. And so Ben was able to push it back down and quick solder those back on.
And that is our presentation. Any questions? Yeah.
It's more of like a thank you to you guys for taking the fall on the fusing of your boards. I was kind of hoping that wasn't going to happen to ours. But at the same time, I was curious to see what would happen if it did happen.
Yeah.
And so
That's what happens if you.
yeah, I appreciate
No more.
yeah, I appreciate you guys taking the fall for finding out what will happen there. For the pick and place machine, did you guys use the really big kind of orange and black one that was in the corner?
Yeah. Yes,
Yeah.
the new one Ben was working on. It did work really well. A lot of them were working, but it's new. He's still getting it configured.
We're also the first ones to
Yeah.
do the pick and place machine. So it was like they're like 1 millimeter off, and
Okay.
I'm just moving them with tweezers. Yeah.
You know how much amperage you put through the
8.
the ones that exploded?
Okay.
Any other questions?
Let's thank our speakers. We have a unique opportunity here because I see several people from the former class. I'd like to just open it up for discussion. If there's questions or feedback or anything.
What are your new machines? Your new machines look so fun and interesting.
Come up for a tour, yeah.
Yeah, I will. Cause what was the picture you guys had in your presentation with the rainbow? It's your second slide, I believe.
Oh, the profilometer.
Yeah. What is that for?
Profilometer, so they used it to measure the trace widths.
Okay. It's just a lot more
Yeah.
accurate than having it over
Oh,
the
yeah.
camera, I assume.
I
Okay.
can never trust the data
No.
calibrated from the other students. So.
Yeah, no, that was always faulty. And you just had to get the line and it always was not right. Was that difficult?
No, it's a whole lot easier to use than the air.
But do you have to still
You still have to like line it up.
okay.
The things that went through the puck, was that like 3 pieces on the edge here?
Yeah.
And then for the alignment, because I know for my group, our big problem is that we didn't realize how important it was to align everything precisely for the first several labs. So there was no hope by the end. Did you use the pins to align everything, like including the,
No, they still use the holes.
oh, they're just better, okay.
Skill issue, actually.
Why'd you stop doing Christmas trees?
Something a little bit more interactive. Nobody recognizes the ERC tree anymore, right?
Oh.
Be the big white
Oh,
pop.
yeah.
It used to be elected to student government and stuff, but nobody really caught on to that one, so. Yeah, these are little chaser circuits, so anybody have one with them? Maybe, but the LED just runs around and they try to get stop in the star, so. No,
Hard. I was playing with it earlier.
not hard to do, but it's kind of fun, a little bit more interactive.
At one point, I got it to have two lights on at the same time. I shot it, popped in two of them, I'm like, okay?
Jackpot then. Yeah. Right, any other feedback or anything?
The etching process, did it, like, I know you guys had some issues.
Way better etching machines than you guys had in the lab.
Okay.
You used the one under the hood.
I bel-
We did.
So you used to splash, yeah, okay.
So I was gonna say, we had a lot of issues with ours. We had to, I think we over etched a bunch, cause the Christmas trees, it was leaving a bunch of stuff on the curves. Do you think the shape helped at all? I know a couple of people, okay,
Well, I don't think so.
okay.
I can't, I'm trying to think back. Their etching was mainly from like so the outer layer wasn't a pour, and so they had some issues recognizing when it was etched through because you can see down to that lower level. So it was a little bit different design than the tree, whereas I think it was double copper pour inner and outer, wasn't it, Emily? I think so. You had your own trickiness to it, which was probably more complicated than what they had. All right. Well, thanks everyone. Any external questions from the external audience? Anybody has anything? Okay.
Nothing from me. Good job, guys. Thanks for sharing.
Thanks everyone for tuning in, and we'll complete L02 on Wednesday. Thanks again.
I wish I waited 2 years.